Let us now see an application about vectors. So we are given that we have two force vectors A and B, and we're asked to find the magnitude of the resultant force and the angle that it makes with the positive x-axis, given the magnitudes of the force vectors A and B, and the angles θ1 and θ2 that these force vectors make with the positive x-axis. Let's first of all consider the positive directions for the x and y axis. So we'll consider as positive the direction of the positive x-axis and the direction of the positive y-axis, and therefore the direction of the negative x-axis will be negative, and the direction of the negative y-axis will also be negative for the components. And therefore, if we analyze the force vector A to its components, we'll have that the x component of the force vector A will be equal to the magnitude of the vector A times the cosine of the angle θ2, and the y component will be equal to the magnitude of the vector A times the sine of the angle θ2. And with the same idea, the magnitude of the x component of the force vector B will be equal to the magnitude of the vector B times the cosine of the angle θ1, and the y component will be equal to the magnitude of the vector B times the sine of the angle θ1. And therefore, the vector A will be equal to its x component, let's call that ax times the vector I, plus its y component, let's call that ay times the vector j. So that would be equal to ax is equal to the magnitude of the vector A times the cosine of the angle θ2 times the vector I, plus ay is equal to the magnitude of the vector A times the sine of the angle θ2 times the vector j. And both of these components are positive since they lie in the positive x and y axis respectively. Now for the vector B, if we analyze that in its components, we have the x component, which lies on the positive x-axis, so it's positive. So we have magnitude of the vector B times cosine of the angle θ1 times the vector I. And then for the y component, since it lies in the negative y-axis, we'll have a negative magnitude of vector B times sine of the angle θ1 times the vector j. And therefore, the resultant force, let's call that vector force F capital, will be equal to the magnitude of the vector A, it will be equal to the vector A plus the vector B. And that is equal, vector A is equal to magnitude of vector A times cosine θ2 times vector I plus magnitude of vector A times sine θ2 times vector j, and then plus b, vector b, which is equal to the magnitude of the vector b times cosine θ1 times vector I minus magnitude of vector b times sine θ1 times the vector j. And if we combine the I and j components, we'll have that the resultant force F capital is equal to the magnitude of the vector A cosine θ2 plus magnitude of vector B times cosine θ1 times vector I plus magnitude of vector A times sine θ2 minus magnitude of vector B times sine θ1 times the vector j. Therefore, the resultant force vector F capital can be analyzed in its x and y component. Let's call the x component fx and the y component fy. Therefore, the magnitude of the resultant force vector F capital will be equal to the square root of fx squared plus fy squared. So that would be equal to fx, which is equal to the magnitude, the square root of the magnitude of the vector A times cosine of theta 2 plus magnitude of vector B times cosine of theta 1 to the square plus the magnitude of the vector A times sine theta 2 minus the magnitude of the vector B times sine of theta 1 to the square. Let us now use the parallelogram law to find the resultant force. So we see that the resultant force is this force, vector force F capital, and it makes an angle theta with a positive x-axis, and we can analyze that force to its Fy and Fx components, to its x and y components, and we see that the tangent of the angle theta will be equal to the y component of the force of the resultant force F divided by the x component of the resultant force F capital. So the angle theta is equal to the arctangent of Fy over Fx. So it is equal to the arctangent. Fy is equal to magnitude of vector A times sine theta 2 minus magnitude of vector B times sine theta 1 divided by the magnitude of vector A times cosine theta 2 plus magnitude of vector B times cosine theta 1.